So those are really interesting temperature effects. And while we're talking about temperature, the next thing that pops into my mind is thermal conductivity, how the heat moves through a material. Some materials, heat can move through very easily. Those are good thermal conductors. And some materials, the heat doesn't move through very well. Those are poor thermal conductors, or sometimes we say they're insulators, thermal insulators. And I'm reminded of this in the morning. I get out of bed, I step on the carpet, not so bad, right? I walk to the bathroom, I step on the tile. Ooh, now I'm awake, right? That tile feels cold. But the interesting thing is, in my house in the morning, everything is about the same temperature. The tile, the carpet, it's all about the same temperature. Why does one feel cold and the other one doesn't? Thermal conductivity. Heat always wants to go from a hot place to a cold place. Heat always wants to go from hot to cold. My feet are toasty warm when I get out of bed in the morning. The carpet's cool. But the heat wants to go out of my foot into the carpet. It tries to go into the carpet, and then it gets stuck. It can't move through the carpet because the carpet is a poor thermal conductor. So it stays in my foot. Then I step on the tile. The heat says, let's try now. Goes into the tile, moves away through the tile because the tile is a good thermal conductor. More heat comes out, moves away. More heat comes out. My foot gets cold. It loses a lot of its heat, and so the tile feels cold. Even my dog understands this. In the wintertime, the dog sleeps on the carpet. In the summertime, she sleeps on the tile. So, maybe you've seen this demonstration before where they spread out those white-hot coals, 2,000-degree coals, and somebody walks across them with bare feet. Maybe you've seen that on TV. I really wanted to do that for you today. Unfortunately, they wouldn't let me. But I can do something very similar. I'll show you in a minute. There's a little bit of physics involved with that demonstration. Those coals are chosen very carefully. They're very poor thermal conductors. You wouldn't step on a good thermal conductor like a piece of metal that's 2,000 degrees. It would be the last thing you ever stepped on. You step on those coals, and the heat wants to go from those coals into your foot and burn your foot. And it tries to, but it can't because those coals are very porous. You know what that means? They're like little sponges, lots of little air pockets. They're very poor conductors of heat. The heat can't move through them very well. So as long as you scurry along and get off pretty quickly, you're okay. So what I'm going to do, I'm going to make something really cold. And I'm going to show you that I can touch it. I'm going to use a graham cracker because graham crackers are very porous, lots of little air pockets. They're very poor conductors of heat. Thermal conductivity.